Hey, straight out of the gate, I just want to apologize. There were some audio issues when I was recording this. I don't know what the deal was. First, there was airplanes in the background making noise, and then I don't know, man. Just with video and audio at the same time, it cut out some of my audio at some of the times. Apologize for that. If you want to help support this channel, these videos take a crap ton of time to make. Like this one right here probably took at least 50 hours to edit. Probably about 50 hours to put together, which is a ton of freaking time. Anyway, if you want to help support the channel, there's a link for Buy Me a Coffee. Much appreciated. Don't forget to like and subscribe on your way in, and let's get to the show. All right, hey guys, welcome back to the channel. In this video, we're going to go over how to hook up the DSS MicroVib II to an EC135 helicopter. It's not too complicated. Yes, and we're also going to talk about the balance screen and all the information that's on that screen, and we're going to talk about the track screen and all the information that's on that track screen. It's super boring, super boring. All right, so fun times. The list of things we're going to go through. We're going to install the balance equipment on the helicopter. We're going to set up a new history file on the MicroVib box. We're going to also review the balance modes and the tracking modes. The next thing we're going to do is we're going to look at the balancing tasks. We're going to go through the tasks, and those are for balancing, which is the ground, the hover, the 80, 120 knots, and 140 knots. Then we're going to review the balancing screen data. There's a lot of information on that screen. Then we're also going to review the tracking screen data. A lot of the similar information, but there's other information there. How to navigate that stuff. It's not too hard. Next thing we're going to do is we're going to show you where to go on to find the DSS MicroBase Pro account and where to go to download the application notes specific for each helicopter or each job you're doing. Like we're going over the 135 today, the Airbus EC135. I mean, they've got tons of helicopter group files and application-specific notes on their website, but you have to have an account to download it. But more than likely, somebody at your company has it, or it's already loaded into your box. And if it's not loaded into your box and you knew what all the specifications were for the group file, you could hand jam it in there and you create your own group file. I've never done that, but the aircraft-specific application notes from MicroVib shows you how to install all of these track and balance equipment. So that's what we're going to go over first, how to install it on the EC135, and let's roll. All right, so the first thing that actually matters is if you go up to the top of your transmission where the lateral accelerometer mounts, it mounts on a bracket that's attached to the swash plate support tube. So if it looks like this, that's a dummy plug, okay? So you got to take that out and put an accelerometer there. We're going to go over this again. But if you have what looks like here, which is a bunch of wires, and it looks like another little mini accelerometer, or if you have this cable that's in the back that's already plugged into the accessory plug, which is where your track and balance equipment plugs into, or you have this, which is in the top of the, you open up the clamshell doors, it's a panel up top. If you have that to access this, that's the VXP. And we only have a couple helicopters that have VXP. We're not talking about VXP, we're talking about MicroVib. So moving on. Nope, this video is not VXP. This video is Dynamic Solution System, DSS MicroVib II. And this is it right here and everything you'll ever want in the kit. With the user's manual right here, make sure you go and reread the user's manual. Like I always say, read the manual, read the manual. Go through this. It's a ton of words, but it breaks it down step by step what we're going to be talking about in this video. And pretty much the basics of balancing and tracking and important parts and stuff like that. And there's a lot of crazy stuff in there that I don't even understand, like root mean squared. I don't know what that means. Anyway, all right, next. Like we talked about a second ago, you're going to want to print up or look at the DSS application notes for the 135 install, and that talks about where you're going to install all these things. All right. All right, where do you find all this stuff? You go to, if you just Google DSS, it's actually dssmicro.com. It's a website. Or if you just MicroVib II, you'll find their website. So you go here and you scroll down to, you click on applications and you scroll down and you're like, okay, MicroVib II application notes. And what's it say here? First thing, you're going to need a MicroBase professional account. Your company should have one. If you own one of these boxes, it comes with an account. Just email those guys. All right, next. All right, how to install the MicroVib equipment onto the EC135 helicopter. That's what this video is all about. And then navigate in the box, of course. Here's your equipment, all right? Here's the cables, the MUX box, optical tracker, and analyzer. And that's how it's all hooked up. And in this awesome picture here, you've got your nice little helicopter. Thanks for the drawing, Jonathan. Awesome. So you take this cable right here. It has two labels on it. One just says DSS EC135, which means it's that cable. And the other part number, I think it says 1372. I can't even see it on the screen. Or 1342. Either way, you'll figure out what cable it is. You take the one end, you plug it into the back of the helicopter, open up the clamshell doors, you take out your stretcher, and on that panel on the left, there's that little cover. Open up that cover, and on the right side is two plugs. The top plug is the plug that you're going to plug the cable that we were just talking about into. The bottom plug is if you had a is to power a strobe, like if you had the Vibrex 2000 or like the old Chadwick 8500, you plug it into there. That's your 28 volt power supply for your strobe. But we're not going to be using that one today. You take that cable and you plug it into the MUX box on the bottom of the MUX box. The next thing is you get your optical tracker, plug that cable into the top of the MUX box. And then your MUX box itself has a cable coming out of it. And then you plug that cable into the analyzer box right there. Next thing you're going to need is you're going to need these two pigtails. I think there's like 4 or 6 in the kit. Grab 2 of them. One's for your vertical accelerometer. One's for your lateral accelerometer. Next thing you're going to need is you're going to need to grab 2 accelerometers. And like I said before, up on the top of the transmission where that bracket is mounted to the swash plate support tube, that is a dummy plug. You're going to have to take out the dummy plug, put in the accelerometer, safety wire it. Put some notes on this on the accelerometer here. There's a threaded stud that has one side has a dimple in it and the other side is machined for an Allen wrench. If it looks like this when you pull it out of the box, this is incorrect. It should look like this with the dimple side sticking out of it. See that? The machine part for the Allen key is right there. The other side has that dimple. Should look like that. Because when you thread this, you thread the accelerometer into the bracket, and then you do your job, and then when you're done and you take the accelerometer out, if that stud stays into the bracket, you're going to need to be able to, you're going to need a way to remove that stud out of the bracket. That's why the Allen key or Allen wrench hole is there. If you have it reverse side, then the only way is to grab it with some channel locks and then you wreck the threads. I have seen a kit that had the threaded stud, had both sides, had the Allen key hole in it. So just a heads up. All right, that was your lateral accelerometer side to side. Now this one's your vertical up and down. So if you open up the door for the co-pilot side, there's that panel for the co-pilot cyclic dual control where it mounts inside of there. So lift that panel up. There's a mirror here, you could see it, but underneath and outboard and maybe just a little bit aft is that accelerometer right there. That's a dummy plug too. So take that out. The dummy plug is 3/4 of an inch. The accelerometers from MicroVib are, I think, 11/16. So you'll need 2 different wrenches, one to remove, one to install, and vice versa at the end. So after you got your accelerometers installed, you hook up your pigtail to it, and then the other side of that pigtail hooks up to the aircraft wiring, and just zip tie it so it doesn't get in the way of moving parts. Flight controls, get it? Safety first, right? All right, the next thing we need to talk about is the mag pickup. That goes on the stationary part of the swash plate. It's on the back side of the swash plate on top of the transmission, but mounted onto the swash plate. That is That is already on your helicopter 99% of the time. The kit does come with one, but it's installed on the helicopter already. You just need to check the gap that's between the top of that and the iron pin. The iron pin that's on the rotating ring of the swash plate. So every time that pin goes over the Meg pickup, that tells the box the position of the main rotor blades for tracking and balancing. And if you notice in this picture where the pin is, it shows the yellow blade right next to it. So if you look at the old Eurocopter chart, which isn't in the maintenance manual anymore, but it shows a little picture of your helicopter and the blades. Well, Airbus's number one blade, or Eurocopter's blade, the EC135 number one blade, is the yellow blade. So, but when you're doing the track with the box, don't get confused, because if we look at this picture, it shows the yellow blade on the back of the helicopter. So if you have the optical tracker out of the front of the window doing your tracking, when the yellow blade is in the back position, the blade that's in the front is the blue blade. So your number one blade on the box is going to be blue, followed by the red, then the yellow, then the green. So we're going to say this probably more than once. I'm going to say a lot of things more than once, because I know I'm talking crazy fast. I'll try to slow down. All right, it's blue, red, yellow, green. Blue, red, yellow, green. So on the box, it shows blade 1, 2, 3, 4. Don't confuse it with the yellow blade being number one. It's not. It's blue, red, yellow, green. Blue, red, yellow, green. You're in a 407 and you're not shooting it out of the front of the window. You're shooting it out of the left. You need to be aware of where the mag pickup is and associated to which blade. Or if you're doing the EC135 and you want to shoot the track out of the side of the window, you need to understand that the number one blade is no longer the number one blade. That would be like the number 4 blade. If that makes any sense. I know that's confusing, but ask me how I know, right? You're like, hey man, I just adjusted the number one blade, the yellow blade, and now it's all jacked up. Well, yeah, because you didn't understand, like, because no one taught you. That's why no one taught me. But that was a long time ago, and that's why I'm here, and that's why I'm making these videos to help you guys out. And we'll get through this together, right? All right, have I said that this is going to be a crazy long video yet? Yeah, it is. Sorry. So now that we have the equipment hooked up into the helicopter, right, so you got all the cables hooked up, the MUX box you usually have in the back seat, you run the cables and the optical tracker up through the co-pilot's seat, and then you just set them there on the floor next to the control panel. That's my setup usually, and I also have a clipboard with paper, all the maintenance manual instructions, because, I don't know, I pretty much write everything down, even though it's saved in the box, because it makes it easier for me to see. But I'm going to make a track and balance video after this video, and we'll go through all that stuff, all right? All right, we have the equipment installed in the helicopter. The next thing we do is you need to make sure you have a group file, an EC135 group file on there, and you could download it from MicroVib Professional, or it should be on there, or you can get it from somebody else. I'm going to assume that you have a group file. Next, the first thing you do after that is you set up a new history file. So you turn on the analyzer box, and if you need the backlighting on, which normally I don't, but in order for me to get good pictures for you guys, I had to turn it on and pretty much turn the lights off. Anyway, you'll see. The backlighting is the left and right arrows together, and the same to turn it off. To set up a new history file, so you hit mode, you hit control panel, you hit new history file, it loads up the group files. You select, it has a bunch that are hardwired in there if you look at the panel on the left and the right, or the columns on the left and the right. And if it's not already hardwired in there, but it's loaded into there, you do the up and down arrows. So you select EC135, then you hit create new file. And then they want you to name it. And, pushing those buttons is like the old phone before the smartphones, trying to text people. It sucks. Anyway, this one I'm going to name 135 HD. Why not, right? Help desk. Then you hit OK, and now you're in the mode section. And in the mode section, the only thing that matters is either it's tracking mode or it's balancing mode. And then, so this one right here is prop rotor balance. See how it's blacked out or highlighted? I'm going to say highlighted a lot, even though it's not highlighted, if that makes sense. That means that one's selected. And if you wanted to do that, you would hit start analysis. And that's how you start doing your balancing. So that's setting up a new history file. We're going to go over it again really quick, okay? You hit mode, you hit control panel, you hit new history file. It loads up your groups that are in the box. You select EC135 group, select group file, you name your file, hit OK, and then you're into the, then it brings you straight to the mode selection page, or the mode page. Cool. All right, that's setting up a new history file. Not hard, but if you didn't know how to do it, you could read the manual, right? You could read the manual. All right, next is we're going to operate the box for track mode and balance mode. And the first thing we're going to do, we're going to be in balance mode for the task ground lateral, which is your first task. But we're going to go through the tasks, okay? Hit task, task menu, and that shows you all the tasks. Ground lateral. Well, so ground lateral selected already, and if you hit start analysis, it'll bring you back to that one. So you want to select different tasks when you're doing the balancing checks in your flight. So if you make an adjustment, you go fly again, it'll log them under each task. So if you go on 5 flights, there'll be a number 5 under each task in parentheses, and you can go back through the history and look at everything. So after ground lateral is hover lateral, then hover vertical, then 80 vertical lateral, then 120 lateral or vertical lateral, and then 140 vertical lateral. Also in here, they've got the tail rotor balancing section. And on the bottom left is the task setup. I guess that's where you'd go to see what all the settings are inside your group file for those tasks. I've never gone in there and made any adjustments, and I don't recommend doing it, because I don't change the sensitivity and all this stuff. No, man, I want it to come from the factory programs, right? Because I don't know. Anyway, so you select the task, then you hit start analysis, and that brings you back to the balancing page like we were talking about. And in this example, I have the signal simulator hooked up because I didn't have an aircraft available to just screw around and do track and balance on for no reason, right? All right, signal simulator comes in the kit. Looks like this. Just plugs right into the box right here. What does the user's manual say about the signal simulator? Let's find out. All right, the manual says this about the signal simulator. It says field calibration check. Using the signal simulator, part number 1117-2, you can perform a quick cal check to be sure that your MicroVib II is reading correctly. Procedures: connect the signal simulator, and the vibration level should read between 0.765 and 0.845 IPS, and the phase angle reading should be between 270 and 274, and the tach reading should be between 1919 and 1920 RPM. If your unit does not read properly, repeat the above procedures to be sure, and then return the unit to DSS for calibration. Cool. In the manual, tons of great information in this manual, all right? Well, the point of me talking about the simulator is that that's what I'm using to get these numbers, and just to show you how to navigate the balancing page, the balance screen. So it's going to ask us to make adjustments, which we're not going to make any adjustments because nothing's hooked up, because we're not actually in a freaking helicopter right now. Make sense? But we're just going to pretend we're in a helicopter. So let's continue pretending. So you get these numbers. How do you run this box? You're on the balance page. So everything starts up. You're outside doing your ground lateral. The helicopter's running. Everything's stabilized. You hit average data. You wait until on the bottom left where it says average, and it counts up. Usually it takes 30 seconds or so to get to 10. You get to 10, you hit stop, and then you hit save run. And at that point, it takes you to the resolution or the solution page, and it says solution for run 1, because we're still on run 1. of the first task of run 1. So it gives you the solution for run 1, still on ground lateral task. It tells you the vibration problems in IPS and the phase angle. And then it tells you a solution. And if you are like, I don't want to, or if it tells you to add weight to the blue blade, but you know you have weight on the yellow blade, which is the opposite blade, you could hit the button new split and it will change the blades. So it will give you the yellow blade option, and at that point it'll be a negative number telling you to remove weight. And that shows that the learn mode is on. Just leave it on. Don't undo it. There's also the view history page. If you've done like 5 runs and you want to view your history at that point, there's a button there for you. Or you could go back to previous. If you select that, it'll give you a warning saying, are you sure? Because you're going to lose all this data. Like if you're like, hey, like you're still in the helicopter, it's still running. You're like, hey, I want to run this again. You hit that. You say, yes, I want to go back. And it will bring you back to the balancing page that you were on previously. And then there's enter changes. So after you're done running it and you shut it all down and you're like, hey, I know what changes I'm going to make. You hit enter changes. You do new split if you need to. And then you type in, you enter the weight that you actually add. You make sure you tell it exactly what you did, okay? So it says it wants 460 something grams. Well, 250 is the max. So we're going to enter, like we entered 250. On the other blade, we didn't enter anything. And then on the bottom, it gives you the predicted vibration level that may or may not be successful. Anyway, after that, hit start analysis again. And now you're on run 2 of the same task. So let's pretend we did 5 runs. I pulled up a different history file out of the box so we could look at it real quick. You hit view history. It shows you, this one had 5 runs. It's the hover lateral. If you hit the button that says view list, it'll give you a breakdown of the history of all the vibration levels. And if you hit the up and down button, you can go to each run, and if the person who was actually doing this job actually typed in what their solution was, like, yes, I added, right here, this one says I added 60 grams at yellow. Then you could see the next run, how that changed everything. But those numbers only come from the guy who typed it in there. So if you want to save a history, like if you only have one helicopter and you're on top of it and you want to keep all your records, then you could have this, and then you could save it onto your MicroVib Pro, and it looks really cool on there. The screen's way better, and it's way more detail than on here. Anyway, I'm blah, 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 and you guys to death again. All right, we were just reviewing the history. Not that matters right now. So we're doing a balance page. So you hit done to get out of your view history page. It takes you back to the balancing mode. Now we're going to go to the track mode. So you hit mode page. Mode. So select rotor blade tracking, then select start analysis. And now we're on the second part of this, which is the track mode for the first task. This is the tracking screen. If you go down on the bottom left is track options. If this is the first time doing it, you just want to make sure, it's set up correctly. On the left side, it has how many blades are in your main rotor. Obviously for us, it should be 4. If you, on the top right is the lead lag, you could display the lead lag. If you select that, it'll be highlighted like on the left side, how that one's highlighted. We don't really need lead lag. You could look at it if you want when you're doing this, in case you think something's crazy going on with your dampers, but you can't adjust for it. So usually I don't look at it. Next is select track distance or set track distance. And for the EC135, it's my understanding that it's 110 inches. And on one of our boxes, a sticker on the box, it says EC135 track distance, track options. It tells you how to go to that page and what the setting is. And I think normally when you reboot your box, like you reset it, it sets it to 200. Anyway, so go there and make sure it's set to 110 for the EC135. The next button under that, it says metric units. If you select that, it'll be dark darkened out or highlighted, it'll change your track picture from inches to millimeters. And if you look at the EC135 maintenance manual, all their limits are in millimeters. And if you've been doing it for a long time like I have, and all you look at is millimeters, it just makes sense. Even though I don't use millimeters for anything else in my life usually. So anyway, it's up to you. Inches or millimeters. Turn the box on and you're out there and you're like, oh man, it's like telling me that it's 1.5 inches. And you're like, man, I don't get it. And because you used to see in millimeters, go to track options, select that, and then hit start analysis, and then you're rolling, okay? All right, next we're gonna be talking about the optical tracker, which is this thing right here. Beautiful optical tracker. If you look on the back side of the tracker pistol, it has 10 LED lights, okay? When it's powered up and ready to do your tracking, the light on the bottom, which is yellow, will just be a solid yellow. Then when you're ready to, all right, when it's time to track, you're gonna pull up this thing, you're gonna hold with two hands, and you're gonna move it up and down until the green light, one of the green lights lights up in the middle. If the red lights are lit up on the bottom, that means you're pointed too high and the blade is below where you're pointing. If the lights on the top are lit up, one of the three red lights on the top, that means you're pointed below and the blade is located above you. You got to get it into the green steady. Like, don't hold this up against a bulkhead or something like that, because you want to remove the aircraft's vibration from this. So don't hold it onto something or hold it all rigid. Hold it all flexible. So if the aircraft's moving around, you're still pointing in the same spot. You're not going like this, right? Makes sense? Once you got it in the green, you push the trigger button and let go. Okay, don't hold it down. Push it and let go. And every time the blade goes by the tracker, the yellow light will flash. And it's, I think the number of revolutions is set to like 32 or 36. You could change that. I never change it. So you just keep it, and it'll go into the red, and it'll go into the red high and low. But you try to keep in the green as much as you can. And then once it stops, there won't be any more color lights up here except for the yellow one. The yellow one will be solid. And then your MicroVib box will show you what your track is, okay? Once it's done and it shows you what the track is, on the bottom left is a button that says Save Plot. It'll take you to a screen to name the file. Just keep it what it is. It'll be plot number whatever. There's 4 digits. It'll be sequentially going and continuing. Plot whatever. And I usually write that down on my form. I usually write down what the track is, okay? We're going to go over that here in a second, but save plot so you can go back and look at what it was. But the thing is you don't know what task this is attached to. It doesn't really attach it to a task. So if you're in a hover and you're doing the track and you're like, okay, I'm doing my hover, I got my vibrations, you write it down, then you do the track, you hit save plot, you write down plot number 0001. That's my hover, because it's in the same section of your screen or your paper. That makes any sense. Because if you just save all these plots and you come back and you're like, I don't know what task I was doing. I didn't know if I was 140 knots or if I was in a hover, because that makes a big difference in your data, knowing what your next move is, right? I know, talking too fast. Sorry, next. All right, now that you have the track done, you're going to go back to the balance mode, and then you're going to select the next task, all right, which is hover lateral. Assuming you don't have a wicked crazy vibration and everything's safe. And you follow the maintenance manual with the correct amount of loading to the aircraft. Like, you're supposed to be in a weight range when you do track and balance, but we'll go through all that in the next video, I'm sure. So you hit mode. It brings you to the mode page. You're currently on the balance mode. Or we were on track mode. So select the balance mode, hit start analysis, then hit task. Go to the next task that you want to do. And this time we're going to do hover lateral. Start analysis. Brings you to the balance page. Again, we just have the signal simulator simulating vibration. Doesn't sound right, honestly. That sentence sounded kind of screwed up. Again, you hit average data. The averages count up to, it'll count on forever, but count at least 10. Hit stop, start stop, which stops it, and then hit save run. Brings you to the solutions page. We're not over that because we're not really doing balance. We're not doing anything right now. We're just going through the box. The next thing you're going to do is you're going to go to the mode page. You're going to go to the track, rotor tracking. What's it say? Rotor blade tracking. Then you're going to hit start analysis. You do your tracking. Then you're going to switch tasks. Go to your next task. Since you're still on the tracking page. And then you're going to switch tasks and you continue and keep going back and forth. We're going to probably go over this again. But note, like there's hover vertical and hover lateral. There's also 80 knots, 120 knots, 140 knots vertical and lateral. Make sure you do those for the vibrations, but you don't necessarily have to go in there and do a tracking twice. Like you don't have to do tracking for the lateral and then the vertical. Yes, I do tracking. I said do. I do tracking twice at least. Once you're good enough to fly and you can do this whole flight regime, you get to hover, you go somewhere where you could go out to start to do 140 knots or as much as you can do, which is usually like 135, 130 knots. Anyway, so you go to 80, you get the vibration and the track. You get to 120, you do the vibration and then both vibrations and the track. Then you go to 140, get the track and both vibrations. Then you turn around and you do it all again, like twice, because there might be wicked crazy wind going this way. And then on the way back, it's not as bad. And also the elastomeric bearings all warm up. So the numbers will usually get better, could get better. And it gives you a chance just to double check your track numbers, because sometimes things just get haywire and you just don't know what the hell problem is. That's just me. I do it more than once. And if the numbers look real wonky, I'll do it like 4 times. I'll shoot my track like 4 times until I get one that I can believe or looks better or doesn't look nuts or is within limits. You know, I don't know. Kind of just going on now. So, all right, I hope that made sense. So you do mode, balance, and you select your task in the balance. Then you select mode for track, and then you go to mode again. Anyway. Okay, I hope that makes sense how to navigate this box and go to each task and then switch from your balance to track modes. It's not hard and you'll get used to it once you start doing it. The problem is if you don't do this, but every couple of years, you're going to forget, which is why I'm making this video just as a quick refresher. All right, next thing we're going to go over is the balance mode on-screen data explained, which is, it's all in this user's guide here, but anyway, we're just gonna go over it real quick. It's not complicated. It's not necessarily need to know, but it's good information to know. Honestly, this might take me a minute. It says dominating the screen is a large polar plot of the vibration level and the phase angle of the vibration relative to the tax signal. This data will update sample by sample in real time. I'm not going to read this whole thing to you. We're just going to go over it though. The next thing is a circle. Like it shows you the IPS level and the phase angle of current vibration. Like you can just watch it in real time. And then when you save the run, it saves in that spot. And the number of the run is inside that circle. All right, in the top left, it says ground lat. That's your current task that you're in. Underneath that is the sensor channels. Not that it really matters, but in case you get things screwed up somewhere, you could figure it out there. You know what channel you're on. Underneath that, it says template name, but it says this is the name. This is the group file or template that your history file was created from. All right, underneath that, it says signal level bar graph. It says the bar graph display, it's a signal level bar graph, and the display that indicates the current full scale range selected by the auto range function and the level of the incoming signal as a percentage of that range. What does that mean? I don't know. All right, on the bottom level, that's your vibration amplitude measured in IPS, or it could be set to metric, which totally screws you up. Millimeters per second. Oh. All right, that's called vibration units, IPS, inches per second. All right, underneath the vibration units and above where it says free run is a rectangled area that it could say alarm in there. If the current vibration level is higher than the user set alarm level, then you're getting an alarm indication there. I don't know what the alarm level is, but I've seen it, and it's not good when you're flying around and you see max vibration level alarm. So heads up. All right, underneath that where it says free run, that's just mean when it's running and you're not averaging data. When you hit average data, it will switch to say average data. All right, underneath that is your RPM indicator, and it could read either RPM or Hertz. I don't even know where to go. It tells you in the box, see section 110.9, probably how to change it from Hertz to RPM. If you turn on the box and it's reading Hertz, dude, I don't even know. All right, it also gives you the phase readout. It gives you the phase angle of your vibration. It's in degrees. And a lot of your charts you look at are in clock angles, so you just got to do the math. It's not hard. But it does also say it's a vibration signal relative to the tach signal, which might be useful if you're balancing a fan or something like that, how to figure out what degree that is in reference to your tach signal. All right, underneath that is the bandwidth. It says the current filter bandwidth is displayed. This is user selectable in the balance option menu. I don't know what the bandwidth is. All right, underneath that, it says FS equals 1.0. That means the full scale range. So right now it's 1.0 IPS. And if you push the up and down arrow, that changes. You can go to 2 IPS, a million IPS, whatever you want to do, or you could scroll down and make it a different size. But this one right here, the full scale is 1 IP. So each one of those circular rings is 0.1 IPS. That makes sense. Basic polar chart. All right, in this little blank area up here, they say it's the update freeze indicator. It's a small flashing indicator that blinks update for every time the sample that is collected and is and displayed. It changes to freeze when you have hit the start stop button, or it shows saved when it's saved, and then you could recall it from the save files. All right, next is your time and date. It's either set and it's correct and it stays that way, or it's all screwed up, but I don't really pay attention, but it's there. It matters if you save your file and you want to go back in like a year and you want to know what day you did this work on. And so that could be useful, right? All right, that's your battery status indicator. It's like a bar graph also, and it also tells you what the volts of the box are. You don't need to keep it plugged in all the time, but just make sure you charge it up every once in a while. All right, underneath that is the file name. And on the top is the screen title. Self-explanatory. Balance run number 1. All right, next we're going to go through the on-screen data for the tracking page. A lot of it's the same, so this one will be a lot shorter. All right, top left, it says hover track. That's the task name, and it's user defined. You could change the name of your tasks if you want. I wouldn't do that though, because you'll get confused. So it's a save plot button. So when you're actually doing your track and balance, when you're doing your track, you save it to whatever file name you want. And then when you bring it back, up here on the top right, that's the file name. All right, this shows you the number of revs. It says the number of revs of data that will be collected before the data is displayed. So I think our box is normally set to 32 automatically. I never change it. There's no need to, unless something crazy is going on. All right, that's the RPM, and it says that the RPM data is derived from the tach signal. All right. All right, this right here, it says camera to blade tip distance. The default value is 200 inches, and you could change this in the track options to whatever. And like I said, for the 135, it's 110 inches. And it says units are fixed as inches. Well, right there, it doesn't say that. It says 490 cm. I'd imagine that's centimeters, which works out to be about 192 inches. Obviously, it can be changed from inches metric to standard, okay? So I don't know. But it's an easy place to see what the tracking distance is set to. So when you're doing the tracking right now, you're like, oh crap, man, it's 490 or 200. Well, it should be 110. You know to change it. All right, those lines, they call them your blade height indicator, and it provides a visual display of the blade height. Obviously, remember blue, red, yellow, green if you're pointing it out of the front of the helicopter. All right, the big number on the top left, that's the distance between the highest and lowest blades. What do they call it? It's a blade track amplitude, so the difference between the highest blade and the lowest blade. And this is set to millimeters. I like it that way. It just makes better sense to me because I've been used to doing it that way, but you could change it. P to P means peak to peak, which, like we said, amplitude, highest to lowest. All right, on the left side, it shows you the scale of this chart, of this graph. It's positive 20 millimeters to negative 20 millimeters. So there's 5 hash lines between the bottom and the top. So that means 20 divided by 5 is 4. So each one of these hash lines is 4 millimeters. So with the range from 20 to negative 20, the first blade looks like it's 4, 8, 9, 10, about 11 up above neutral. If you push the up arrow, it zooms in the scale. See how it changed from 10 to negative 10, top to bottom? And the triangle on the top left means that the first blade is out of range because it's over 10, which we know that already. So now with the 5 hash lines divided by, well, 10 divided by 5 equals 2. So each hash line is 2 millimeters. So with that said, the second blade looks like it's a negative 6.5. The third blade is a negative 9.5. And the fourth blade is a positive 5.75 millimeters. Just write all that down because it's easier for me just to have it on a sheet of paper to look from one flight to the last flight to see the changes at different whatever speeds. It's just easier for me to do that than to go through here and scan around. So it says 490 centimeters, whatever. If it doesn't say 110 inches like it's supposed to, you hit track options. Pretty simple. And then you could hit the set track distance and get it to where you need it to go. Cool. All right, we went through a crap ton. Just a quick review, setting up a new history file. It says it right here in the manual. What's it say? Mode, control panel, new history file. Select a group file, EC135, hit enter or OK, change the name. Then you're starting in the balance mode. You go from different modes, which are the task and the balance. Those are the only 2 modes we're going to worry about. There is also spectrum analysis, which is cool. It's something that you should probably do. We'll go over that later. Like if you just get a general once over of your aircraft. If you're like, hey man, I got wicked weird vibrations, but all my numbers look good at 120 knots vertical. You do a spectrum and it tells you what frequency it's at. We'll go over that some other time. Also, you want to get to a MicroVib Pro account. It makes it way easier to look at the graphs and the charts, and also you could send that information to other people. You could just download all the data you want, like your application notes or your group files. It's super easy. I'm going to put in screenshots of each task in the task setup page to show you what the settings are. So if you needed to set up your own group file, you could do that there. Also, from MicroVib Pro, which I don't have on this computer, I've got it on a different computer, which isn't my computer. You could print out a 1-page sheet of the group file. So I'm going to attach that to the description. So if you're like, holy crap, I don't have a group file, I'm about to do track and balance tomorrow. Well, at least you could go to create group file. In here, it'll tell you how to create a group file. Go to whatever, and then you will know what all numbers they're supposed to be. Like you'll have to program each task, like 120 knots lateral, channel 1A, sense factor 1000, tack factor 250.0, skip factor 0, units, grams, 1, 2, 3, 4, location, blue, red, yellow, green, angle 0, 90, 180, 270, rad 1.0. I think that's rad. Anyway, what I'm saying is that's a crap ton of data. And there's a way that you could print that out on one sheet of paper, is what I was reading out of the manual. So I'll put that in the description, or if I could attach that file. You know what? I'm going to ask permission. I'm going to reach out to DSS more than likely after I publish this video, and see if I can add links. Like I have a Google Share Drive that I could link to this description in this video for the group files and the application notes for a bunch of different helicopters. If they're cool with that. They may not be, right? But I'll do what I can. So yeah, if someone's asking questions about your track and balance, and you make sure you type in all of what was your adjustments you made, and then you could download it to MicroVib and you could send them this stuff. And then you'd be like, hey, this is what happened. This is what I did. This is exactly what I did. You guys made it this far. You guys are superheroes. I hope you appreciate the show. Give me a thumbs up. Share it with people who might need to know this information. There's a link. Buy me a coffee. You know, I'll take donations. Why not? Not too proud. Thanks for watching, liking, subscribing. I appreciate it. And I'll see you guys next time. All right. Later.